Today's lesson is about the theorems about roots of polynomial equations. So we're going to learn about the rational root theorem. First of all, I want you to factor each of these numbers. So pause the video, determine all the factors of these numbers, then come back and check your answers. All right, for 12, 24, and 44, did you miss anything? Hope not, because you're going to be needing this kind of information to work the problems today. The rational root theorem. If we let p of x equal this function to be a polynomial with integer coefficients, think of what an integer is. The negative numbers, the zeros, the 1, 2, 3s, your counting numbers, okay? Then there's a limited number of possible roots for p of x equals 0. Integer roots must be factors, but we can also have rational roots. We find rational roots having the reduced form p over q, where p is the constant term that's in the polynomial, q is the leading coefficient. So let's look at our steps to finding rational roots. First of all, you're going to list all the possible rational roots. And then you're going to test each possible rational root. You could also use synthetic division if you would like to evaluate. Depends on which you like to use best. So we're going to find the rational roots of this polynomial function. 3x cubed minus x squared minus 15x plus 5. We need to list all the possible roots for our constant term, which is 5, and the leading coefficient, which is 3. Because by the rational root theorem, the only possible rational roots of the equation have the form factors of 5 over factors of 3. So we could have a 1, 1/3, a 5, or 5/3, plus or minus, because negative times a negative would give us a positive as well. So these are our possible rational roots: a positive or negative 1, positive or negative 1/3, positive or negative 5, positive or negative 5/3. Do you see how that works? Now let's test out each of those roots. We said 5 or negative 5, 5/3, negative 5/3. All we're simply doing is substituting in for x in our original function to see if we get a true statement. As we look here, as we're checking each of our solutions, we find the only one that is true is 1/3. So that tells us that the only rational root of this polynomial function is a positive 1/3. Let's try another one out. We're to find the rational roots of this function. So our constant again is 5. This time our coefficient is 2. So we're going to list all the factors of 5 and 2. Our possible choices, if we've got p over q, would be a positive or negative 1, positive or negative 1/2, positive or negative 5, positive and negative 5/2. We need to check our answers. Again, remember, you can also use synthetic division if you would like, but these are all of our choices for factors. Do we have any true statements? Yes, we do. Negative 1. So negative 1 is the only rational root of this polynomial function. Okay, time for you to practice a little bit on your own.